Welcome, and settle in as the room around you grows quieter and the day loosens its hold. Tonight, you and I will drift solely into the patient flicker of bioluminescent bacteria, those tiny companions of the night sea whose soft glow has guided sailors, shaped symbioses, and gently lit the edges of waves for longer than stories remember. If this calm corner helps you rest, a soft tap on like and subscribe helps more sleepy science find you. And there is a quiet playlist in the description that can keep playing while you drift, so you never have to worry about choosing the next video. How sleepy are you on a scale of 1 to 10? Imagine yourself on a wooden deck at night, with the ocean breathing below you. The air is cool, and it tastes faintly of salt. The hull hums softly, a low and steady sound. The sky is a dark dome, and you can almost feel the curve of the earth under it. Your eyes adjust slowly, and you begin to notice a milky tint along the edges of the wake, a pale, almost hesitant blue-green that lifts and settles with each gentle curl of water. It is not a spotlight, not a burst, just a hush of color, like the rhythm of your breathing turned into light. The gentle rhythm continues, and you notice the quiet certainty of that glow. It feels patient. It feels ancient. That soft color is the work of bacteria, so small that 1,000 of them might line up across a grain of sand. They do not rush, they do not hurry, and yet they breathe light into the sea. Their names are tenderly spoken in laboratories and on tide-washed dock bucks. Alevibrio fischeri, Photobacterium phosphoreum, and cousins in the Vibrionaceae family. They thrive where the sea is right for them, in water stirred by currents and rich with tiny bits of drifting life. They do not shout their presence. They simply make a dim radiance, the quietest lanterns, a color the ocean carries particularly well. Blue-green, around 40 nanometers, a shade that glides through seawater as if the water itself was made to hold it. As you breathe, imagine oxygen entering your lungs. The bacteria, too, breathe in their own way. They use oxygen not only to live, but to paint with photons. A small enzyme they carry, luciferase, carefully guides a reaction that releases light. In their little world, a molecule called FMNH2 gives up energy, and a long-chain aldehyde yields to oxygen, and the energy released by those chemical movements pauses for a heartbeat in a quantum space and slips into the world as a pale blue-green photon. That word, luciferase, is simply a name for a bearer of light. In these bacteria, the glow is continuous when they are ready. Not a flash like a firefly, but an open and steady lantern, patient and deliberate. The gentle rhythm continues, like a candle that never quite wavers. The ocean absorbs red and yellow, and so the bacteria speak in the language the water loves to carry. The blue-green flows, bends, and reaches the eyes of fish and squid and quiet watchers on the deck. Your eyes, tuned for darkness, welcome that color with ease. Your pupils widen just a little more, slow and calm. The longer you rest here, the more details you notice. A whirl that swirls off the stern, a soft chain of speckles drifting behind a fish, a swirl of brightness around a falling leaf of seaweed. These tiny points of light are not random decorations. They are a conversation between the cells and the sea. A conversation spoken in density and chemistry, in patience and timing. In the hidden gather of their world, these luminous bacteria do not glow alone. They listen to one another with molecules. They wait until they are together in sufficient numbers, and then they gently agree to shine. This quiet agreement is called quorum sensing, and it is as calm and communal as a village deciding that the lamps along a road should be lit when the evening grows deep. Each cell releases a small signal, an acylhomoserine lactone, and each cell carries a matching receptor, a listener. As the cells drift closer on a leaf of marine snow or settle within the folds of a host's light organ, the signals accumulate, the listeners begin to hear, and a threshold is reached. Then, softly and together, the lights come on. You can imagine it in the most hushed way. A tiny cove deep in the folds of a squid's mantle, protected from the turbulence of the open water. A handful of bacteria arrive, brought by currents too small for us to feel. For a time, they are silent, their whisper of signal molecules barely brushing the receptors. But daylight passes and dusk comes again. More cells arrive, and the signals gather strength. The receptors begin to notice. A switch is thrown gently inside the cells. A set of genes with names like Lucca, Luxb, Lux, Luxd, and Lux begins to hum to life. Luciferase is made in peaceful lines of proteins. The aldehyde-making machinery readies its quiet work, and together, like fireflies that have decided not to blink, they begin to glow and keep glowing. For some fish and squid, this quiet light becomes a tool, a way to blend with the sky. Imagine a small bobtail squid near the seafloor, no bigger than your palm, resting in sand flecked with shells that feel cool to the touch. Up above, the moon hangs over the water, and even when the night is thick, a faint brightness filters down from the stars and the moonlit surface. Predators below see silhouettes. A dark body against a lighter sky gives away the squid's shape. So the squid invites bacteria to live in a special organ on its belly. There, the bacteria are fed, bathed in oxygen, and gently cared for. In return, they glow exactly as bright as the moon and starlight above, matching the sky. The squid vanishes. Counter-illumination, in the gentlest sense, is simply being there without being seen. You find yourself inside this story as if you were holding a shell to your ear and hearing the ocean's murmur. The squid's light organ is not a simple lamp. It is a small theater with curtains of muscle, mirrors of reflective proteins, and apertures that can open and close with the delicacy of a slow breath. The squid adjusts the brightness that leaks out through filters of tissue, shading the light until it blends. The bacteria have their work, and the squid has its subtle tuning. Each dawn, the squid vents many of the bacteria back into the sea, a quiet release as regular as the daily tide. Each dusk, a few newcomers are invited in, and the gentle relationship resumes. The gentle rhythm continues, as predictable as morning and night. In the cool and slightly sweet smell of a laboratory by the water, plates of agar rest like shallow pools, and colonies of photobacterium resemble tiny stars under dim room lights. A researcher looks with calm steadiness, seeing a faint glow that strengthens in silence after the room is darkened and the eyes adjust. The plates are warm to the touch, but only just, like stones left in the sun and brought inside. A notebook turns a crisp page. The scientist writes about a growth curve, about oxygen in the medium, about a gentle rise in luminescence as the culture slows from growing to simply being. There is no rush. Bacterial light blooms most in patience, not in the hurry of division. The halo around each colony tells a story of metabolism easing into a rhythm where the energy for light can be spared without strain. There are whispers of light like this in many corners of the ocean. The flashlight fish, with a name that feels like childhood, hosts bacteria in a small pouch under each eye. The fish cruises through shadowy reefs, cave mouths, and quiet lagoons. The water there is thick with the smell of life, damp limestone, and dissolved salts that taste metallic on the tongue of imagination. The fish opens and closes a shutter of tissue to modulate the glow, sending signals to kin and illuminating plankton to feed upon. The light is not a flare, not a beacon that startles, but a steady pulse, an open eyelid slowly closing. The bacteria sit in their organ like guests at a well-set table, fed by the fish, and the fish receives a calm, blue companion in return. Other fish carry luminous partners in bellies and along their flanks, tiny houses of light that point down, sideward or forward, painting soft arrows into dark water. Ponyfish gather in schools over the sandy floor, their bellies flickering in a hush, turning their sides toward each other as if passing notes. In all of these scenes, the bacteria are there as artisans of light, crafting the signal with an economy and grace that would make any maker proud. The chemistry of light begins to feel familiar, like the gentle sound of your own breath. FMH2, which forms as cells gather energy from their food, meets oxygen, always a subtle presence in the ocean, and they cradle a long-chain aldehyde produced by a trio of molecules, the Lux-CDE team. Luciferase guides them into one another, and the energy that would have shaken the molecules apart is steadied, lifted to a higher step, and allowed to step down by releasing light. The light is not a waste. It is a way to control the energy of oxygen reactions, to manage the chemistry of living in the presence of oxygen without harm. Some researchers have suggested, softly and thoughtfully, that the glow provides a safe path for reducing oxygen, that luminescent bacteria manage the energy of oxygen like a potter's hands guide a spinning bowl. The gentle rhythm continues, and the cells are safe. The sea is a place where processes repeat, and repetition is a comfort to sleepy minds. Currents travel, tides rise and fall, and bacteria turn over with them. On a night when the wind is very light, sailors sometimes report a steady, horizon-wide glow. Old logs call it milky seas. It is not bright like day, not even like the moon, but it is stronger than the little flashes in the wake. It fills the water like ghostly milk, whitish, blue-tinged, the kind of glow that holds steady when the ship moves. A blanket spread for hundreds of kilometers. The air above feels like velvet. The horizon is softer than usual, and the ship's rails glint with dew. In those nights, great rafts of luminous bacteria may gather, riding on abundant organic pieces, fed by surface waters. Their quorum sensing becomes a chorus. The light they make is unblinking, like a page under a dim lamp. Modern sensors riding satellites, orbiting far above, have gently caught these nights in their own way. The day-night band, a very sensitive detector, has noticed patches of the Indian Ocean glowing faintly, patches that stay in place through nights and nights. Their shape changing slowly like the turn of a cloud. A boat on one of those seas reports a surface that glimmers in the wake with no bright flashes, just the steady light. Looking down, you might see your own reflection softened by the glowing water, as if your outline were made of fog. This phenomenon is still being understood. There is no rush to explain everything. The ocean keeps some secrets behind curtains of time and distance, and the study of gentle glows invites patience. In quiet laboratories, the genes of luminescent bacteria are often used as soft markers, like a pencil line you can see in the dim. The lux operon can be placed into other cells so that those cells glow when a particular process is active. Instead of harsh measurement tools, scientists can watch for a glow that rises slowly. Ecology studies use luminous bacteria as sentinels that dim when their environment is harsh and glow more when conditions are right. A flask on a bench looks like calm tea until the room lights dim, and then a mild blue-green haze reveals that the cells inside are speaking about their chemistry without any voice but light. The smell is faintly sweet and yeasty, the comfort of warm medium and glass. The gentle rhythm continues. Imagine drifting down through layers of water. Above, the ripples of the surface still wobble the starlight. Then the water becomes a place of shapes and movement, small animals sweeping their delicate limbs, long threads extending, tiny crustaceans paddling with a slow, earnest cadence. Tiny flakes of organic matter drift here, called marine snow, simple rain in the sea. On these surfaces, bacteria find a home. In the twilight zone, the far-off day is a dim memory, and the glow of bacteria makes the falling particles into soft lanterns. Fish with wide eyes, whose faces look attentive and patient, glide through and collect these luminous crumbs. The bacteria travel within those fish for a time, and when the fish pass them along, the bacteria return to the water, ready to gather again. In this way, the glow may help each microbe find its next home, help it cross the wide spaces between small places like a bridge. Your breathing slows with the rhythm of the current as the story opens and closes like waves on a shore. In some altars of the deep, such as the mouths of vents and the slopes of islands, larger animals host their own luminous bacteria. Anglerfish carry organs that hang like lanterns, though many of those lights use other chemistries. Some anglerfish, however, carry bacterial companions that fill a small pouch hanging in front of their jaws. In the calm dark where pressure is firm and steady, the bacteria glow and the anglerfish waits, patient beyond measure. The glow is a way to be noticed by prey that drift closer, and in return, the bacteria live in regular food and oxygen. In this muted theater, the bacteria's light rewrites the darkness into a scene of soft movement. The timing of glow often follows the light above. Some luminous bacteria grow brighter in the evening and less in daylight, even when kept in constant, gentle conditions. The squid, as it vents its symbionts at dawn, keeps a daily pulse that invites new colonists at dusk. This is not a dramatic heartbeat, but a slow tidal motion. There is something restful in imagining that somewhere a tiny organ opens its vents at daybreak and closes them at night, while bacteria settle into place in patient small steps. You can feel the texture of this world. It is not smooth like glass. It is textured with currents that flow like fingertips across a tabletop, with fine sediments that settle as lightly as dust on a book cover, with flakes of life that drift like snow through beams of light. The glow of bacteria is part of this texture, not a layer on top. It deepens the experience, rounds the edges, makes the sea seem like a place where even the smallest business is handled with care. The way the glow begins in a culture is gentle. In early growth, the cells are busy making more cells, splitting and enlarging like slow pulses. The lux genes are quiet. Energy goes to building. Later, as nutrients thin and the culture thickens, the signals accumulate. The gene circuits slip into place, and light begins. The first time you see it in a dark room, it feels like a breath held and then released. Colonies on a plate darken the room with their soft presence and make the air feel cooler, though the temperature has not changed. The gentle rhythm continues and time stretches. The physics of the color is also a soft thing to hold. Blue-green light travels far underwater because water molecules and the particles in seawater do not pull that color down as quickly. The world beneath the surface is tuned to this color, and the rods in our eyes that see in low light draw it in with ease. When you imagine the glow, you can imagine that your vision slips into a comfortable mode where edges soften and contrast lowers, and all the in-between shades feel important. If you picture a light organ under a microscope, imagine tissues not as slices and stains, but as gentle folds like silk ribbons laid into a small box. Bacteria nestle into crypts, and cilia move slowly, stirring the water like tiny oars. The host provides oxygen like a fine mist. The bacteria glow and release the byproducts of their controlled reaction. The tissues nearby are careful, filtering what passes. Each morning, before the sun lifts fully, the host relaxes the organ and releases many of the bacteria, seeding the water around for other host juveniles to find. The cycle repeats, soft and sure. In a quiet storeroom of a marine station, you might find jars of old notes, drawings of luminous trails painted in thin ink, edges blotted by the humidity. The fishermen who wrote these notes never hurried their words. They described nights when oars carved light and days when salt dried on their cuffs. They speak of the patient flicker that stayed with them as they mended nets, the way the waves left after images on their eyelids when they closed them before sleep. The story they told is not about giants, storms, or tall luck, but about small things that persist. In workshops and classrooms, students gently move pipettes and pour soft agar into plates. They inoculate with a loop, drawing a figure on the surface that will become lines of light. They turn off the lights, and the room breathes. The glow shows them that the biology they learn can be seen without noise, without heat. They talk quietly, not because they must, but because the scene encourages it. The glow makes people soften their voices in a way that touches old instincts. The gentle rhythm continues. They leave the plates open for a moment, then close them and step away, watching through the lid as if the bacteria might feel the draft. Within the cells, the circuit that turns light on is designed by evolution with a kind of simple elegance that makes one feel a slow respect. Lux I, which makes the signal, and Luxor, which listens for it, form a pair that together control the Lux operon's voice. When the signal is low, Luxor waits. When the signal rises, Luxor binds it and gently encourages the expression of the genes that make more luciferase and more of the signal. This is positive feedback, not a storm, but a falling into place where a small increment becomes a steady state. The threshold is not sharp like a cliff. It is a slope that becomes a plateau. Now, imagine a bay at night with a village not far away. The distant sounds of people are muffled, and the houses play small square reflections on the water. A child steps into the shallow surf, and the footprints bloom in turquoise. Each step stirs tiny organisms, and the bacteria in the water are sometimes part of this scene, along with drifting algae. As the feet lift out of the water, the prints fade, not suddenly, but with a polite delay. The child raises a hand to chase a moth in the air, but the hand returns to the water to make a line that glows. The coolness around the ankles is precise and calming. A shore crab settles, little legs tapping, bathed in its own faint trail. In the quieter corners of a city, far from the sea, the same light is invited into experiments that do not smell of salt. The Lux genes are placed into plant tissues to watch when a promoter wakes after the sun sets. In a clear greenhouse, rows of seedlings glow like tiny constellations when watered with a particular nutrient that nudges a pathway. In a room with controlled air, a culture of bacteria designed to sense a pollutant glows more as it detects what it is meant to measure, serving as a gentle monitor. It is not dramatic, not alarming. The glow is a simple report. The scientist writes the time and the intensity in a log and closes the book. Sailors have long recorded that in the ship's wake, the glow is strongest where the water is stirred. Mixer propellers, paddles, and hulls draw oxygen deeper, and the luminescent bacteria, sensitive to those shifts, respond. The reaction that makes light is oxygen hungry, and the extra oxygen carried by those currents feeds it. The resulting light shows the shapes of turbulence like a map. It is a relief to trace those shapes with your eyes because they move in patterns that our minds find calming, spirals, eddies, and smooth decays. The gentle rhythm continues, and the wake is a long ribbon of soft luminescence that extends behind a boat until the sea closes and the glow finds a new form. In tales told on nights when there is no wind, the milky seas invite an almost meditative attention. On such nights, even the small noises of a ship seem arranged in a slow cadence. The creak of rigging is a metronome. The water does not slap, but pats softly. The watchman's footfall is a kind drumbeat, and the glow removes any sense of unlit danger. Darkness becomes a surface you can touch. You can lie on the deck, gaze forward, and feel that the ship moves through a wide river of luminous silk. You're safe in the slow present. There is no rush to arrive anywhere. The evolution of this light is gentle in its logic. To be seen is sometimes to be sometimes to be found, and sometimes to be invisible by matching what surrounds you. Luminous bacteria have found a way to turn energy and oxygen into a signal that helps them move through their world. When they glow on floating particles, fish come and eat those particles, and the bacteria travel to new places. When they glow inside hosts, the hosts benefit and protect them. When they glow in vast sheets, their environment may be one that nurtures them. The costs of glowing are carried by a metabolism that has had time to fold the reaction into its routines. There is no wastefulness here, only slow-fitting adaptation. From a small boat on a calm night, you can trail your hand into the water and watch the points of light stream from your fingers like threads. The water is cool and silk-like. When you stop moving, the glow fades to a slight presence, like a letter on a page after you look away. Your hand, when lifted, feels slightly tingly from the cold, and drops fall back, each a small line with its own tiny tail of light. You can lean forward and smell the wet wood of the gunwale. You can taste salt on your lips from the mist. The gentle rhythm continues, and drowsiness creeps kindly into your limbs. Some luminous bacteria are picky, preferring water within a narrow range of salt and temperature. In those settings, their enzymes fold and unfold at a comfortable pace, brisk enough to make light, but not so hurried that the cells become spent. The patience of the glow is in part a reflection of this. When cultures are made warmer, sometimes the glow rises and falls quickly. When cooler, it rises gently and rests. In the sea, currents bring warmer and cooler tongues of water into contact, and the glow maps those contacts like contours. For researchers, the gentle curve of a luminescence versus time plot, drawn in pencil or pixel, is a pleasing shape, with shoulders and soft peaks. It looks like a sleeping landscape of hills. The life of luminous bacteria in a host environment is also shaped by simple flows. Hosts supply sugar and oxygen. Bacteria supply light and perhaps other slow gifts. The bacteria do not crowd into one corner. They form thin films, communities where each cell sits with enough space to breathe. The signal molecules that shuttle between them make a fog of communication that is not loud or quiet, but just present. In biofilms, the glow can become a sheet. Put your mind close to that sheet, and it feels like a calm meadow lit by fireflies that have agreed not to flash, but to glow together in a constant tone. In literature and journals, the first recorded observations of the sea glowing like milk are described with restraint. Writers note the date, the wind, the temperature, the phase of the moon. The glow is noted as a steady light that did not flicker with the oars. The gentle rhythm continues through their descriptions. Later, scientists compare these stories with satellite data and find that the old words match the new numbers. There is a comfort in that. The patient glow that people saw then and see now spans centuries with ease, like a lullaby that parents pass to their children. The water, even when it is lit, remains soft and dark. The glow traces the edges, but leaves plenty unfilled. This leaves your imagination space to rest, to settle into the gaps. The ocean is large, and in this calm narration, we do not try to fill it, we float. We notice that light is in many places involved in conversations that do not need voices. Bioluminescence is a conversation with predators, mates, and neighbors. In the bacteria's case, it is also a conversation with the environment, which they calm by guiding oxygen into light. It is a mutual care, a pacing that suits the night. In the ship's galley, a kettle steams quietly. A cup of tea warms your hands. Through a porthole, a moony glow rolls by with each gentle swell. The angle of the cup reflects a wire of light. You take a sip and taste, see, and sleep. In the lab, a recorder plots a line, and it slopes upward with a softness that pleases the eye. The gentle rhythm continues, and the difference between the boat and the bench feels smaller. In both places, patient measurement and patient glow meet. The community of bacteria in their host does not stand still. At dawn, in the life of the bobtail squid, the light organ opens, and the bulk of the symbionts are let go in a controlled release that looks like smoke underwater. The remaining cells bloom again in the evening. Day after day, the pattern repeats, a tidy housekeeping that keeps the organ responsive. Juveniles catch the released bacteria easily because the water nearby has become familiar with them. The bond forms again. In this, one can sense why the glow feels patient. It has time built into it. There is no immediate need, no sharp switch. The entire system breathes over hours and days. In aquaria, caretakers who raise luminous fish adjust their lights to match the ocean's day and night, and they find that the fish's glow follows. Under red illumination, which is a color the deep sea ignores, caretakers can watch without disrupting. They report that under these conditions, the fish swim in patterns that look like writing that you cannot read, but that you feel is kind. The light organs open and close with cadences that suggest comfort and conversation among the fish. The gentle rhythm continues, and the room feels like a shrine to patience. When we think about the genomes of these bacteria, the Lux genes sit together like friends on a bench. The opening and closing of their expression is controlled by a promoter that listens to Lux R, which listens to the signal. The pathway to make the signal uses small enzymes that build an AHL from a molecule of S-adenosylmethionine and an acyl chain. The molecules involved have names that are not needed for rest, but their actions are slow and kind. The loops they form in space are steady, and they dock into place like pebbles settling in a stream. In engineering and art, people have used luminous bacteria to draw. They place the cells into stencils, and overnight in the fridge, the patterns appear as gentle lines. When the door opens, the light emerges from the dim interior like a whisper. The designs are simple: leaves, waves, a moon. They are not bright enough to light the room, only to make you lean closer. The smell is cold and briny. After a few hours at room temperature, the glow fades slowly, not all at once, like the end of a song. If you sit quietly and imagine the microscopic world of a luminous colony, it becomes a tiny city with soft lamps. The cells line up in small streets formed by the agar's pores, with oxygen flowing down those alleys. In the deeper parts of the colony, oxygen is less and the glow dims. At the edges, where the air meets the surface, the glow is brighter. Patterns emerge like halos and gentle gradients. In a time-lapse, the light patterns shift like weather. It is absorbing to watch, but not demanding. You can let your attention drift in and out. The gentle rhythm continues. Scientists who study these patterns sometimes model them with equations, gentle curves standing in for signal molecules and enzyme rates. The plots they show are learning tools that feel like lullabies to to a mind that enjoys balance, the thresholding of quorum sensing, the feedback loops that create stability, the diffusion of signals through a colony, all form lines that slope and level. None of these shapes are jagged. The models carry you along like a slow river that never rushes or drags. They explain just enough to make comfort, not to startle. On land, there are other bioluminescent creatures like fireflies and glowing mushrooms with their own chemistries, but they pulse and flash and rhythm in ways that might stir you. The bacterial glow is different. It is the nightlight of the ocean floor, the steady lamp in the window. If one learns to recognize it, one begins to feel less alone under large skies. The glow has been with the sailors in calm and with scientists in contemplation. It has been with squid resting in sand and fish drifting in lagoons. It has been with us quietly the entire time. Around the midpoint of our drifting, as your body loosens and your eyes grow heavy, we invite a gentle moment of connection, still awake. Comment the secret word, nebula. Now imagine that you're walking along a pier with old planks and your footsteps knock tiny puffs of dust into the air. The night is damp and the sea is dark. When a fish turns near the surface, a curve of light marks its path. If you lean over the rail and toss in a pebble, the rings of luminescence move outward like whispers spreading. Each ring fades at the speed of a sigh. A gull in the distance beds down on a pylon, tucking its head under a wing. Lights on distant boats are softened by haze. The gentle rhythm continues. Your breath takes its time. In stories told on fishing boats, the glow sometimes helped them come home, tracing the shape of waves and shorelines when clouds covered the stars. The glow is not bright enough to guide a course by itself, but it offers comfort, and comfort is a kind of guidance. There is a kinship between the calm that the glow offers and the calm this voice hopes to bring. Both say that patience is enough. A scientist once described that when they cultured luminous bacteria, they noticed that shaking the flask gently increased the glow, and stopping took it back down. And they felt a small smile at the predictability. Oxygen swirls in when shaken, luciferase finds its partners more easily, and light is emitted. The quiet satisfaction of watching an expected result happens is restful. The gentle rhythm continues as experiments, ships, and organisms are all governed by the same simple physics of fluids and the same simple whisper of oxygen and energy. In coastal villages, people sometimes notice that the shore glows more after warm days when the water has been still. And when a late breeze arrives to tip the water into motion, the glow appears like a memory of sunlight reshaped. Children run and trace letters none may read, but they enjoy the sensation in their bones of motion creating light. Elders watch from benches and breathe in the salt, and if they speak, they do so in low tones, as if light could be scared away by noise, though it cannot. Within cells, a small detail is how the long-chain aldehyde is renewed. Lux C, Lux D, and Lux form a trio that gently rebuilds it after each photon is released. This is a cycle, a wheel that turns with the slowness of metabolism, not with the twitch of nerves. The wheel has no teeth that grind or cause friction. It spins renewal after emission, and the emission after renewal in a relationship that feels like rocking in a chair. The gentle rhythm continues, a molecular cradle. In the deep sea, where pressure is constant, and motion is slow, light becomes news. It travels far because the eyes there are unblinking and wide. A small glow carries far in the imagination of that world. Bacterial light in those settings is like a letter read quietly by someone who knows that any louder and it would echo. The light paints the edges of bodies, making outlines crisp in a place without sun. These scenes unfold not with noise, but as if everyone agreed to whisper. The sensory details of a night like this are simple. The taste of salt, the smell of kelp drying on a dock, the touch of rough wood under a palm, the sight of light in water that moves at a human pace, the sound of a sentence read slowly. These things are enough. The glow almost seems to bring other senses into focus by offering a single gentle stimulus that the mind can step into and back from at will. The gentle rhythm continues and the body follows. People sometimes wonder whether the glow signifies health for the bacteria. Mostly it does. A luminous culture that has what it needs glows more steadily. When starved, the glow subsides. In the sea, when food is abundant and oxygen patterns are kind, the glow appears more frequently. This too gives comfort because it suggests that when we see the glow, the small lives that make it are okay in that moment. One could rest simply knowing that something is well in a small corner. As you breathe, imagine that each exhale is a thread of warmth that curls and dissolves. In the same way, the photon produced by a bacterial reaction finds its way outward and dissolves into space. It is absorbed by water molecules and turned into a little bit of warmth, too small to feel. The path from chemical to light to warmth completes, and everything returns to a baseline. There is no net imbalance, only motion. The gentle fluorescence that you see at beaches is sometimes due to other creatures who flash when disturbed, like dinoflagellates. But bacteria prefer to glow steadily when their quorum says they are together. This difference is a clue for your attention. Flashes come from sudden triggers. Steady glows come from arrangements that have come to rest. The bacteria's patience stands out in this chorus, and we honor it tonight. In the pale attention of moonlight, algae mats near shore sometimes shelter luminous bacteria in their damp layers. When the tide pulls back and the mats are left on rocks, if you press gently and cup your hand over, you may see a low glow, a last murmur before the cells dry. The smell of iodine from the algae and salt from the spray is clean. As soon as the tide returns, the mats soften and darken, and the bacteria go quiet until they are restored by immersion. The gentle rhythm continues, tied to the tide itself. The movement of hosts with light organs can create patterns that postal carriers of light carry into the sea. In schools, fish turn together and produce waves of glow that roll along the group. This coordination feels like music set into motion. Each individual is a note. Together they form a chord that arpeggiates across the water. The music is visual. It asks nothing but your time. In barns near harbors, nets hang, catching small breezes. The smell of tar and wet rope mixes with coffee and fish. In these places, the glow is sometimes a story told twice, 3 times. In the quiet of early morning, when people sit and let body and mind wake slowly, those telling the stories often involve their hands in the telling, making arcs in the air that reflect the arcs of the wake that once followed their boats. The gentle rhythm continues, and listening to them becomes like watching the diet. The complication of science is a good place to rest. Simple elements arranged with care bring forth a phenomenon that is more than the sum. The reaction yields light because the enzyme cradle sets a stage where energy can leave as a photon. That photon is the least disruptive way to let go of the extra energy. The cell's interior is protected from heat and harmful side reactions. The reaction's gentleness is part of its value. In the sea, that gentle quality resonates with the overall calm of the night. For a moment, imagine that your breath and the ocean's swell match. As you inhale, a swell lifts. As you exhale, it lowers. Within that rhythm, points of light rise with the swell's face and slide down its back. The glow is not stronger at the top, not weaker at the bottom, merely present. The water's skin catches sky glimmer, the body carries bacterial glow, and the boundary between surface and depth holds the conversation between moon and microbe. The gentle rhythm continues, and each repetition makes the memory of it more deeply embedded in your mind. Sometimes, in quiet lakes near the sea, brackish water hosts luminous bacteria that have drifted up estuaries. The glow is fainter there, but in still coves it shows. Between reeds, fish disturb the water with small V-shaped wakes. In these small places, the glow feels intimate, like a candle on a table. The hum of insects surrounds the scene, and the air is warmer and stiller than the open ocean. The light becomes a private sign between water and watcher. In the night, when fog drifts low and cradles a harbor, the diffuse glow of bacteria in the water lends the fog a faint aura from below. Boats move slowly. Horns are soft. The bridges above wear beads of condensation. The city sounds are cut by the fog's blanket. This is a time when even mechanical noises become gentle. The glow reinforces the sense that the world has taken a slow breath and is holding it. Back in a laboratory, years pass, and the patient study of luminous bacteria refines understanding. People share findings quietly at conferences, in rooms with chairs and soft carpet, where projectors hum and coffee smells mingle with paper. Slides show images of colonies, of milky seas from space, of fish with glowing organs half open like gentle shutters. Questions are asked in kind tones. People nod. The gentle rhythm continues, and science feels like a community reading a poem aloud, one line at a time, savoring. In some strains, luminescence is stronger under certain nutrient balances, where the ratio of carbon to nitrogen sets a comfort level. When carbon is abundant and growth slows, the glow has more resource. This reflects a principle that the sea itself follows. When growth is quick, structure and change dominate. When growth pauses, expression and rarity come into view. The luminous reaction is an expression. The sea, too, expresses itself when calmed by weather and tide. Imagine the genomes of fish and bacteria that host each other aligning over evolutionary time, not as an imposed shape, but as a mutual smoothing. The host evolves tissues to house the bacteria securely and deliver oxygen in measured doses. The bacteria evolve to glow exactly in the right range for the host's optical filters. Together, they produce lighting systems that mimic moonlight. The match is not perfect in one step. It is refined over generations, each one laying a tiny layer of polish. The result is that the organ feels like a naturally carved shell rather than a machine. The gentle rhythm continues, carved by temp. As you lie here listening, your muscles untangle themselves from their day-long holds. Shoulders drop. The back of your neck warms gently. The bed holds you evenly. The air does not move quickly. It is a slow companion. The voice in your ear is steady and asks for nothing but your time. The glow in your mind's eye is not bright. It is a nap for the eyes. If thoughts come and go, they are like small fishes making loops in the light, leaving lines that fade. If one were to watch a bacterial culture all night, one might see its glow rise after sunset and hang like a crest until dawn. Then it lowers as oxygen flows change and the culture shifts back to building. This is not a sharp sunrise or sunset. It is an estuary of light where two rivers meet and mix. The gentle rhythm continues, crossing from night to day and back without any abruptness. In museums, exhibitions sometimes include tanks where visitors see softly luminous water. The lights in the room are low. Children press noses to glass. Parents point and smile quietly. The tanks are labeled with the names of the organisms and a few simple lines of explanation. No alarms, no warnings, no urgent pleas, just an invitation to notice. In this way, the glow becomes a lesson in observation, the calmest kind of learning. The gentle rhythm continues, and people leave with a memory that reappears when they stand in the dark, later that night brushing their teeth. The patient flicker in bacterial communities comes not from individual flashes, but from any spatial variations and the movements of water, which introduce the appearance of a slow twinkling. If you looked long enough at a large area, you would see patches subtly brighter than others. A plankton cloud here, an oxygen tongue there, a ripple passing. The overall scene feels like a quilt with a pattern of stars. Each square of the quilt has its own quiet texture. The eye can roam and never be jarred. In a cove tucked behind a headland, the water lies almost flat. The light slipping through eelgrass shines like threads woven into a rug. A seal's head appears and leaves a circle of glow. A night heron steps and pauses, and the footprints in the shallow form a dotted line. A paddleboarder moves with a slow stroke and leaves a painter's stroke. In these moments, people remember to move more slowly than usual. The glow asks, and they comply. The gentle rhythm continues. The energy budget of a luminous cell is accountable. Only a small fraction goes to light. In the cost, the benefit is companionship, whether with neighbors or hosts, and movement, whether onto a particle or into a fish. Those benefits are not immediate. They add up over time. This is why a slow mind sees it. A slow mind accepts that the best things unfold. The reactions, the quorum, the ecological loops, all encourage letting go of hurry. The gentle rhythm continues, and what needs to happen, happens. When you picture the luciferase enzyme itself, you can imagine a small cradle with curved surfaces that hold the reacting molecules. The cradle is not rigid, it flexes lightly. When oxygen arrives, it is not thrown in, but placed. When the photon is ready to leave, there is space. The pool of water that surrounds this cradle is not a static coolant. It is a friend that carries away the heat gently. The entire scene is suburban, with neighbors who wave softly, with lawns that meet, not fences. The bacterial glow is sometimes harvested in simple devices that allow remote sensing of water quality. A living light meter. A small vial is filled with luminous culture and placed in a device with a photosensor. As the water sample is added, the glow either dims or brightens depending on the sample's kindness. The device records, and the operator reads a value. This is a measurement used in environmental care, and its softness suits the role. It is a non-invasive question answered by non-invasive light. The idea of self-organization is often explored in the context of quorum sensing, where individuals who know only their own small neighborhood nevertheless produce a global effect. It is reassuring to think that no central control is needed for such beauty. Cells whisper and listen, and from this, the sea receives a glow that can reach beyond the horizon. Similarly, in your own life, small, patient habits produce an overall calm that carries beyond the moment. The gentle rhythm continues in bacteria, in the sea, and within you. And while you continue to drift, the night around you deepens. The horizon keeps the same distance, but the stars rotate gently, making small arcs. In the water, luminescent eddies move more slowly now as the tide shifts. The ship, or the pier, or the shore where you sit, breathes with your breathing. The glow is less something you look at and more something that sits with you, like the quiet presence of someone you trust. You could sleep to this, and that is the plan. As we come quietly to the end of this shared evening, the glow remains in your mind, not as a bright image, but as the idea of patience embodied by small lives. The patient flicker of bioluminescent bacteria is a promise that not all light arrives with noise. Much of it arrives with courtesy. You might feel the mattress beneath you a little more, the pillow cradling your head, the blanket weighted just right. Your eyelids are heavier, and the room is friendly. If this gentle journey helped you relax, we would be grateful for a like and a subscribe so we can keep releasing calm science this often. And if you want soft stories to roll on as you drift, the playlist in the description is there to carry you through the night. Rest well, feel safe, and let the patient glow keep you company as sleep tucks you in.